Now you might be wondering what's the difference between stage.stageheight and stage.height. Well, whenever your ball leaves the stage, for example, when it's right here, the stage width is still the same, and your stage.width and stage width are going to be equal. But when the ball leaves, all of a sudden our stage is from here to here. So basically, stage.width represents the width of everything on your stage, even when it leaves the boundaries. So that's what stage.width is. However, stage.stagewidth, this over here, represents only the original stage width values that you specified over here in the size. So that's what we want. If bottom is greater than stage.stageheight and the ball is moving downward, then trigger our collision. So that is it for our check boundary collision as soon as we add the code here. When it actually hits a wall, what we want it to do is, first of all, we'll, just in case it actually was moving really quickly and went past the ball, we want to move it back so that ball.x equals ball width divided by 2. So ball.x, the middle of the ball, is going to equal its width. So this is 0 and this is its width. So in case it passes the wall, we want to move it back so that it's against the wall. That's what that code is. So first of all, we move it so that it's against the wall. Then we also want to flip the velocity so that it bounces the other direction. So Vx is going to equal Vx times -1. And basically the same thing over here. We want to set it so that it's against the right side, and Vx times equals -1. And the top is the same idea, but the bottom side, when we get to it, is going to be a little different. So, but for the top, let's ball.y equals ball.height divided by 2, set it against the top side, and Vy is gonna, well, flip. Now for the bottom side, let's see, first of all we want to do the same thing in terms of putting it against the ground. Ball dot height divided by 2. Yeah, that looks right. And we also want to flip the vertical velocity, obviously. However, if we just multiply it by -1, what will have happen is the ball will just bounce forever, and it will never, because when the ball actually hits the ground, it's supposed to diminish a little bit and eventually come to a stop. So we don't want it to just continue forever. We want to diminish it by multiplying it by negative, I guess 0.8 maybe. But instead of doing that, whenever you have constants like these, it's good to declare a constant up here so that you can change these values and easily. So we'll call it bounce factor. And we'll set that, yeah, to 0.8. Bounce factor. So that's good. But now the problem is, if we run this, we have it bouncing, which is cool. But if we were to have an x velocity, let's say it begins at 10, it bounces, so far it looks, okay, the boundary check is obviously wrong here. When it hits the right side, I spelled width wrong. You guys probably saw that right when I was typing. Let's test it again. Okay, it bounces and bounces, but now the problem is, unrealistically, the ball is now bouncing forever side to side. So let's also have it diminish in the horizontal velocity every time it hits the ground. So Vx times equals bounce factor. So I guess bounce factor kind of represents any kind of dimming effect whenever it hits a surface. So now let's look at it. Yeah, that's a little better. Okay, so now we have our check boundary collision completed, and that sums up our enter frame handler function. We have gravitate the ball, move the ball, check the stage boundaries for collision. Obviously now we need interactivity. Mouse down handler will first check to make sure we're clicking on the ball and not just anywhere else by doing if E, which is the mouse event that is passed in. E basically contains a lot of information concerning the event that caused this function to be called. So E dot target describes which movie clip, which displayable object was clicked on. If it equals our ball, in other words, if our ball is what was clicked on, then we want to act upon it. Otherwise, we'll do nothing. And what we do when we hit the ball is, once again, it's going to be more than just a couple lines. So let's go ahead and declare a new function. In this function, what we will want are coordinate values of just where in the ball we hit, because when we hit on the right side, we want the ball to move to the left. When we hit on the left side of the ball, we want it to move to the right. Same thing with up and down, kind of. Generally, since this is just a game, we want it to bounce upward every time, even if you click up here. Also, the bounce force is going to be greater when you hit farther away from the center, which also kind of makes sense, because if you're thinking in 3 dimensions, if you hit over here, it's going to move away from you more than it is going to move left. So anyway, that's why we want to send in the coordinate values of exactly where on the ball you clicked, which is going to be defined by E.target, which is our ball, dot mouse x is basically the x coordinate of your cursor relative to your ball coordinate, which is the center of the ball. And we want to do the same with the y coordinate. And now let's declare our hit function. And we'll call it hit x, which is a number, and hit y, also a number, and returns nothing. Alright, this isn't too long of a function. First we want to adjust the vertical velocity of the ball, and then we want to adjust the horizontal velocity of the ball. And finally, actually that's about it.